Okay, so today we're going to be talking about multiplying binomials. So I first want to talk about what a binomial is. A binomial is a polynomial with two terms, and a polynomial is basically just an expression, which is basically an equation without an equal sign, and there's two different terms to it. So this is an example of multiplying two binomials together. We have x plus 3 is one of the binomials because it has two pieces to it, and then x plus 2 is the other. Sometimes people don't really know what to look up when they see examples like this, but this is what we're going to be doing today. And I'm going to show you two different methods. The first one's going to be the box method, also known as the area model, and then I'll also show you the distributive property, which they use a lot on Khan Academy. So first off, I want to go back to basics with the box method and think about how we would multiply 5 times 6. Now you may already know that 5 times 6 is 30, but I want to have us think about how we used to visualize that way back when we were multiplying two things together and actually physically adding up 30 pieces. And this visualization is really using that formula of doing length times width equaling area. And we're going to think about that same visualization when we're multiplying x plus 3 times x plus 2. Basically, we want to think of the first parenthesis as the length and the second as the width. And we want to think about how the area of the box is going to look with these two sizes here. Now, of course, we know how long 2 would be and how long 3 would be, but how long is x supposed to be? Because that's just an arbitrary amount. Well, we're going to actually consider it as being an arbitrary amount. We can think of sort of like this purple length of a piece to be having a length of x, and we're adding 2 units onto it, and the same to be true for this other piece up here that's the length of x, adding 3 units onto it. And so when we think about finding the area of multiplying those two together, we actually end up with a box that has 4 different sections to it. And just to focus your attention on the parts that are important, we have basically the side lengths of the purple box to be an x by x, and this box in the top right is a 3 by x because that's the length of this purple box. And then we have a 2 by x in the bottom left, and then a 2 by 3 in the bottom right. And what we're going to do is basically find the area of all 4 pieces and then add them together to get the total area of this box here. Okay, so for the purple box, we're going to be multiplying x times x, which is x squared. For the upper right box, we are multiplying this length over here, which is x, times 3. X times 3 is 3x. In the bottom left box, we're multiplying 2 times the x up here to give us 2x. And then in the bottom right, we're multiplying this width of 2 times this length of 3. 2 times 3 is 6. And what we're going to do next is add up the area of all 4 sections to get the total area. So the first one is x squared plus 3x plus 2x plus 6. And we can conveniently combine like terms here. We can combine 3x and 2x together. So we'll bring down the x squared. 3x plus 2x is 5x plus 6. And so this is actually the solution when you multiply these two sets of parentheses together, when you multiply those binomials. I want to do one more example with you from start to finish just to show you this is a lot faster than it seems without my explanation. And we also can use negative numbers in this model. So we're going to multiply these two things together. I'm going to start by drawing my box. And remember, the length and width of the box are represented by each of these sets of parentheses. It doesn't matter which one you put as the length or width in your actual box. You could, put x minus 4 on the top and x plus 7 on the bottom. Be very careful to make sure that negative is right in front of the 4 so you know that they're attached to each other, because that's going to affect what we get for our areas in here. And I know it's kind of hard to sort of wrap your head around having a subtraction there, but this is going to work for us with the box method. So I'm going to multiply x times x to give me x squared, and then x times negative 4 to give me negative 4x. And then 7 times x to give me 7x. And then 7 times negative 4 to give me negative 28. And now we just add all 4 areas of each of the sections together to get me the total area of the box. And so we'll get x squared. You can go ahead and combine these like terms ahead of time if you want. 7x minus 4x is 3x. And then we have minus 28 at the end. So I want to show you another method that some people prefer, and this is using the distributive property. They use this method a lot on the Khan Academy videos when they're multiplying binomials. And so what we're essentially doing here is we know that, for example, if you had 5 times x minus 7 or something like that, we would use the distributive property to multiply those out to get 5x minus 5 times 7 would give me negative 35. We're going to use that same thought process here when multiplying these binomials by each other. So I am going to actually multiply x plus 3 times each of these terms over here. And we usually like to write a single value first, so we're going to be multiplying x plus 3 times x. Let me just write it out with parentheses to show you. I wrote the x first, which is this one right here. X plus 3 times x is what I did there. And then we're going to multiply x plus 3 times 2. So I'm going to add on the 2 times x plus 3 as well. And now I actually have to use the distributive property again. We have these other sets of parentheses that we need to continue to simplify. So x times x is x squared. X times 3 is 3x. Then we're going to add on what we get when we distribute this 2 out. So 2 times x is 2x, and 2 times 3 is 6. We're going to go ahead and combine like terms. 3x plus 2x is 5x. And bring down the x squared. Bring down that 6. And there we have the same answer that we got before. Back when we did the box method with this example, we also got x squared plus 5x plus 6. So both ways are perfectly fine to do, and you can do whichever method you prefer. So with this second practice problem, we actually have the same one that we did for our second example with the box method, and I'm going to show you how Khan Academy does it using their method next.